Welcome to Aljazari channel, where you will learn engineering graphics. I'm still in teaching you how to convert 3D drawing into 2D drawing by making or by drawing the three views of an isometry as the one shown to you now. So for this example, it is required to draw three views: the front view looking to the part from this direction, the top view looking to the part from this direction, and the left side view looking to the part from this direction. The dimension of the front view is 90 millimeter and 70 millimeter, while for the top view it is 90 by 70, and for the side view it is 70 by 70. Before explaining how to draw these three views, I am reminding you and asking you, if you didn't do yet, please subscribe to Aljazari channel and activate the alarm to be notified of the new videos. As I used to do, I draw three rectangles to draw the three views inside them. This is for the front view, 90 millimeter by 70 millimeter. This one for the top view, 90 by 70 as well, and this one for the left side view, 70 by 70. So I will explain how to draw the three view using this 3D model. So the front view, as I told you, it is in this direction, so means looking to the part from this direction or perpendicular to this surface. So I will rotate the part like this. So we have to look to the part in this direction to draw the front view. So this edge is the lower limit of the front view. This is the right limit. It is aligned like this, and this is the top limit, and this is the left limit. So from the bottom, what we see? We see this shape. So this length is the entire length of the front view, which is 90 millimeter. And what about this height and this height? These two heights we can get it from the drawing, and this length as well. So for the right one, the height is 30 millimeter. For the left one, this one, the height is 20 millimeter, and for the length of this one is 30 millimeter. So what about this length and this length? Actually, these two lengths are not given in the drawing, but we can get them. So to get them, we have to draw this inclined line. This surface is represented in the front view by inclined line. So we have to draw this line at the beginning so we can know this length and this length. So what we will do, starting from the front view, we will go up by 20 millimeter, then go right by 30 millimeter from this side. Then from this point, we will go to the left by a certain distance, then draw a line connecting this point to this point. So we draw, in this case, we draw this inclined line. After that, from this point, we will measure 30 millimeter and draw a horizontal line to the left till it intersects with this inclined line. So no need to know this length. So what about the length of this line? It is there in the drawing. This length is 20 millimeter. So let us now do this in the sheet, in the drawing sheet. Here we will draw the front view. Starting from this point, I will go up 20 millimeter, then go right 30 millimeter. So from this point, go up 20 millimeter, 10, 20, then draw a horizontal line with a length of 30 millimeter till this point. So this is the horizontal point. Then from this point, I will draw another horizontal line. It is already exists, but I will measure 20 millimeter, then make an inclined line. So here, from this point, 10, 20 millimeter, and make a point. Then connect this point by the point I just drew like this. So this inclined line representing this line. For this edge, it is represented by horizontal line from 30 millimeter from this point. So I will go from this point to go up 30 millimeter, then draw horizontal line till it intersects the inclined line. From this point, go up 30 millimeter, 10, 20, 30, then draw horizontal line like this. So now I finished this surface, represented by this surface here in the top in the front view, and this one represented by this surface in the front view. Here we have a space, so this means that these two line segments should be erased. The same what we have in the part we have in our drawing. The next view is the top view, which means we should look to the part vertically from this direction. So this edge is this line, this edge is this line, this edge is this line, and this edge, it is one edge, okay, it's represented by this line. So if we start from the left, we will see this rectangle. This rectangle is bounded by 4 sides, as you know. These 3 sides are already exist. They are here. So we need a 4th one here. Where exactly? We can get the dimension from the drawing or from the front view. This line is represented in the front view by this point. So aligned with this point, we will draw a vertical line in the top view like this. So this rectangle here. So what else do we have? We have this inclined surface as L shape, and we have 2 other rectangles. So I will start with this one. This rectangle has a dimension of 20 millimeter, the same as this length, and another dimension here we will get it from the drawing. From the drawing it is 30 millimeter. So from this corner I will go to the left by 20 millimeter, then go down by 30 millimeter, then make a horizontal line like this. So this rectangle represents this one. Another rectangle here, this edge is represented in the top view by this line, by this point, sorry. So aligned with this point, I will go down like this. But why I started from this point? Simply because this edge is the extension of this edge. So I will extend this line like this. So now I finished this rectangle. Once I finished these 2 rectangles, this shape is generated. So I don't have to find the dimension of this L shape. It is a drawing, or it is a result of drawing these 2 rectangles. Now I finished the top view. So let us go now for the left side. The left side view is to looking to the part from this direction. So this is the right border, this is the top border, this is the left border, this one, and this is the bottom. So from the bottom we have here a rectangle. Because this rectangle is perpendicular to our side, it is represented by a rectangle with its true shape and true dimension in the side view, while in the front and the top view it is represented by 2 lines. These lines are these 2 lines, this one and this one. Of course the length is the entire length of the side view. So aligned with this point, I will draw a horizontal line like this. So this rectangle is this one. Above this rectangle there is an L shape. This L shape is inclined, so it is showing as L shape but with a dimension, not true dimension, in the top view, and the same in the side view, while in the front view it is represented by this line. So this length we can get it from the top view. It is this one. This edge is represented here by this line. Its dimension is 30 millimeter. So from this point I will measure 30 millimeter and make a point, and from this point I will draw a vertical line, but till where? Till where? Till this point. So the end of this line is this point. And this point, from this point I will draw another horizontal line like this. This edge and this edge representing this rectangle. Okay, we have a space here, so this means that we have to erase these 2 points, 2 lines. So review again. So we have here this rectangle and this L shape and the space. Now I finished the 3 views of this part. Before finishing this video, I need to review something with you. At the first video, I give an introduction about how to draw a different surface. If my site is perpendicular to a certain surface, it will appear in one view as a true shape with true dimension, and in the other views as a line. While if this surface is inclined, it will appear in two views as shape with approximately the same shape with different dimension, and in the third view it will be a line. So if we apply this here, we have here this shape or this surface. This surface is vertical, so when I am looking to the part from this direction, from the front view, my side is perpendicular, so I will see it as a true shape with true dimension in the front view. While in the side view and the top view, it will appear as a line. In the top view, it will appear as a line, this line, and in the side view, it will appear as a line as well, this line. Another surface, this surface, it is horizontal, so my side will be perpendicular on this view, on the top view, if I'm looking from the top. So in the top view, it will appear as a rectangle with its true dimension. In the front view, my side is parallel to this surface, so it will appear as a line, this line. The same in the left side, it will appear as a line, this line. Another surface, this one again, this is a vertical surface, so in the front view, my side is perpendicular to this surface, so it will appear in its true shape and true dimension. In the side view, it will appear as a line, this line. In the top view, it will appear as a line as well, this line. For this surface, because it is inclined, so in the side view and the top view, my side is inclined to this surface, so it will appear like this, L shape, but the dimension is different. Okay? While in the front view, my side is parallel to this surface, so it will appear as a line like this. So we can review each surface in the part to see if it is represented in our three views or not, to see if we missed something or we did something wrong. Hopefully you understand and you can draw three views of any part by yourself. In next video, I will solve more examples. So keep following us and subscribe to Aljazari channel if you didn't do yet. If you like this video, press like and share it with your classmates. See you in the next video. Goodbye.